Introduction. Calculus' foundational idea of differentiation deals with how quickly a quantity changes. It is an area of mathematics that focuses on the behavior of a function when changes are made to its input or independent variable. The derivative of a function which expresses the function's rate of change with respect to its input is found during the differentiation process. The slope of the tangent line to the function's graph at a given position is indicated by the derivative of function fx, also known as dy over dx. Put more simply, it explains how a function's output varies as the input varies little. A common interpretation of the derivative is the instantaneous rate of change. The power rule, product rule, quotient rule, and chain rule are important ideas in differentiation because they offer methods for determining the derivative of many kinds of function. Derivatives are utilized extensively in many disciplines, including biology, physics, engineering, and economics, to optimize functions, model and assess rate of change, and comprehend the behavior of systems. All things considered, the differentiation is an effective mathematical tool that is vital to comprehending and characterizing the dynamic nature of functions and their interaction. As the foundation for numerous sophisticated mathematical and scientific application, it is a crucial subject to learn in calculus class. 2.0 Theory of differentiation. 2.1 Differentiation using first principle of derivative. The process of determining the gradient function dy over dx, or the first derivative of function fx, is by using the idea which known as differentiation using first principle. First principle of differentiation help us to evaluate the derivative of function using limits. Here are the formula. This formula can be used to find the derivative of function fx by using first principle. For example, given the function is 3x power of 2, and by using the first principle, we can substitute the function with 3x power of 2. Next, we can divide the numerator by h, and last, we must substitute 0 into h. And the derivative of function 3x power of 2 is 6x. 2.2 Rule of differentiation. 2.2.1 The constant rule. The graph of a constant function is a straight line parallel to the x-axis. It shows that the line has a slope that is constant with a value of 0. Therefore, the derivative of a constant must be 0 as well. When the function is constant, then the answer is equal to 0. For example, given the function is y equal to 5, and after the differentiate, the derivative of y equal to 5 is 0. Next, 2.2.2 The power rule. Given the formula for the power rule is nx, the power of n minus 1, the n can be any real number. For example, given the function is y equal to x power of 4, bring the power in front of the function and reduce the power by 1, and the derivative of y equal to x power of 4 is 4x power of 3. The scalar multiplication rule. The formula for this rule is c times dy over dx of the function, which means c can be any real number. For example, given the function is y equal 3x, bring the power in front of the function and reduce the power by 1, which means 3 times 1 times x power of 1 minus 1. Solve the equation, and the derivative of y equal 3x is 3.
The product rule. This given formula can be used in product rule. Now, let's get through on how to use this formula. In the given equation, there are two functions which are 5x to the power of 2 minus 3x and 2x to the power of 4 plus 4. So, firstly, let u equal to 5x to the power of 2 minus 3x, and let v equal to 2x to the power of 4 plus 4. Then, differentiate both u and v, and you will get the answer for du over dx is equal to 10x minus 3, and for dv over dx is equal to 8x to the power of 3. After that, substitute those by using the given formula. Then just simplify the equation. The quotient rule. The quotient rule can be used when there are two functions in fraction form, and this is the formula used to solve the problem. Now, let's look at the example. Same goes to the product rule. There are two functions which are x to the power of 3 plus 1 and 2x to the power of 2 plus 2x. First, let u equal to x to the power of 3 plus 1 and let v equal to 2x to the power of 2 plus 2x. Then differentiate both u and v and you will get the answer 3x to the power of 2 for du over dx and 4x plus 2 for dv over dx. After that, substitute those by using the given formula. Then, simplify the equation. The chain rule. Given the function, set 2x to the power of 2 plus 2. To differentiate this function, first, copy the function 2x to the power of 2 plus 2, then bring the power to the front of the function and reduce the power by 1. Next, differentiate 2x to the power of 2 plus 2. And lastly, solve the equation. Derivative of the exponential function. This is the result of differentiate the exponential function. Now, let's get through the example. Given that y is equal to 4 plus e to the power of s in bracket to the power of 2. Same goes to the chain rule. Copy the function first and bring the power to the front and then reduce the power by 1. Then differentiate 4 plus e to the power of x. Next, simplify the function. Chain rule for exponential function. To differentiate the exponential function, first copy the function, then multiply it by the derivative of the power. For example, y is equal to e to the power of 3x plus 1. First, copy the function, then just multiply it by 3, which is the derivative of 3x plus 1. Then we will get the answer. Derivative of the natural logarithm. This is the result if we differentiate ln x. Now, let's move on to example. Given that y is equal to x to the power of 2 times ln x. To solve this, apply the same method as product rule, which let u equal to x to the power of 2 and let v equal to ln x. Differentiate u will result 2x and differentiate v will result 1 over x. Then, solve the equation by substituting into the formula. Chain rule for logarithmic function. This is how to differentiate logarithmic function. Example given, y equal to ln 2x to the power of 2 plus 1. First, differentiate the function and divide it by the original function. Then, you will get the answer. Higher order derivative. Higher order derivative is differentiation process that can be continued to find third, fourth, and more derivative of a function. For example, find the third derivative of the function fx equal to 3x to the power of 4 plus 2x to the power of 3 minus 3x. First, differentiate the equation for the first time. Then, continue to differentiate the equation for the next derivative.
3.0 Application of differentiation. Rate of change. The rate of change of quantity can be expressed in the form of derivative. Rate of change of one quantity with respect to another is one of the major applications of derivative. The rate of change of a function with respect to another quantity can also be done using chain rule. 3.1 Application in Physics. Example 1. Find the acceleration with respect to time at the instant when t equal 5, given that v equal 1.6 t squared plus 5, where v is the velocity and t is the time in second. Acceleration is differentiation of v. Differentiation of v is 3.2 t when t equal 5. The v differentiation of 5 is 16. The rate of change after 5 minutes of volume with respect to time is 16 meters squared. Application in economy. Differentiation was used to calculate marginal function to economy. Marginal analysis is rate of changes in economic quantities. If X is the number of units of a product produced in some time interval, then total cost equal fixed cost plus variable cost. Average cost divide X. Total revenue X multiply P. Average revenue divide X. Total profit equal revenue minus cost. I will be giving you a few examples to understand the application. Example 2. There is the function. Number 1 question is, what is the cost to produce the 31st smartphone? There is how to calculate, and the answer is Ringgit Malaysia 295 ringgit and 91 cent. Number 2 question is, what is the rate of change of the cost at X equal 300? And the answer is Ringgit Malaysia 296.
The advantages and disadvantages. The advantages of differentiation. It can help in finding the rate of change or slope of a curve at a given point. It is useful in optimization problems such as finding the maximum and minimum values of function. In business, differentiation focus strategy, which narrows the focus of differentiation towards the specific market segment or niche. The weakness of differentiation. It can be difficult to solve complex functions with multiple variables and partial variables. It can be time-consuming to find higher-order derivatives. It can strain resources. Pursuing a differentiation strategy means a lot of time, energy, and resources will be spent to develop a product that sets itself apart from the competition. This can put a burden on research and development team, product manufacturers, and even your profit margins. Conclusion. To sum up, differentiation is an essential calculus topic that is crucial to comprehending and deciphering function behavior. We can learn more about the rate at which a quantity changes in relation to its independent variable by using the derivative method, the power rule, product rule, quotient rule, chain rule, and other fundamental differentiation principles and methods offer an effective toolkit for investigating the dynamic nature of function. Our comprehension of the graphical depiction of functions is enhanced by the geometric interpretation of derivatives as the slope of tangent lines. Numerous disciplines, including physics, engineering, economics, and biology, has extensive use for derivatives. They are essential for modeling and resolving issues with optimization, rate of change, and behavior of dynamic systems.